All right, guys. Questions about homework?
Yeah, Professor, this is Angel. And I think I emailed you a couple of questions. I'm having particularly, well, I think I solved, what is it? E, basically with the numerical integration of both the centroid and the moment of inertia. If you could provide more examples, maybe that would clarify it.
All right. Okay. Can you, let's say, pick a specific problem you're having issue with? You say
E and G. But if you
2E and 2G.
Yeah.
All right. Okay. Yeah. So we can go over it. Anything before that? Anybody else have issues? After. Okay. All right. So let's look at 2E and 2G. So let me switch. How do I? When I switch, I won't be able to see the question. Okay, let me use my laptop for the question. Okay, so the coordinates given to us are basically 0, 2, then 1, 2.5.
Yeah, 1, 2.5, and 2 and 4.
So we're only given these 3 data points. We don't know whether they should be joined with a parabola or.
No, it says they're joined by the first question is to determine the.
Hold on. Wait. When you're given real world data, you only have 3 points. You don't know whether the actual function looks like this or whether it looks like this. Okay.
We cannot see. I cannot see what you're drawing.
You cannot see the docam?
No.
Can anybody else see the docam? Weird. Did I not share screen?
I see the screen, not the docam.
Okay, you see the docam, right?
No, the screen of what's on your computer.
Sorry. Wait. Let me. Is Zoom frozen now? Come on. Okay, wait 1 second. Okay. Now good? All right, perfect. So yeah, that's the 3 points that we are given. And this is, let's say somebody gives you temperature every day. Okay, day 1, day 2, day 3. The temperature in between day 1 and day 2 might do something weird. We don't know that. All we have available are these 3 data points. So we don't know whether the real function would look like that or like that. But the first question, what it says is, okay, the best we can do with this is we can approximate it using a parabola. We can't do any better, okay? So that's one option. But the reason to do that is to compare what happens when you do this analytical fit and integrate versus what happens when we use the numerical formulas directly. When we use the numerical formulas directly, you don't have to do any fitting. All of that is implicit in the formulas. Okay. So what was all right, we're given the okay. Does it make sense now why we cannot? We don't know whether the real data follows a parabola. Okay. No. So somebody was saying this looks like a parabola, correct? But we assume that this looks like a parabola. In reality, it might be something else. Okay, let's see. What is E? Compute the centroid coordinates numerically using trapezoidal rule. Okay. So we basically have to compute the coordinate of, let's say, the flap that would form when you join all of these points. I'm assuming you were able to do this analytically, since that's the previous question. So xc is double integral x dA over double integral dA. And when you simplify all of this, you get x f of x dx. So you were able to do the bottom part numerically? Is that okay?
Yes, I was able to do the area numerically.
Okay, perfect. So that you can compute numerically, that's just the area by using numerical integration. The top part is not very different. We just have to make one simple change. So what? So this guy is what looks different from the bottom, correct? That you know how to do the bottom numerically. That's probably the only thing that's causing you trouble. So the only thing we do is we call this a different function, g of x. Okay, and now you can use the same integral method that you did for the bottom. So I'll write out a few steps and then it'll become more obvious. So integral of let's say f of x dx. How do we do this using the trapezoidal rule? So we say this is I equal 1, I equal 2, I equal 3. And which one do you want to use? Do you want to do trapezoidal? Okay.
Yes, please. Yeah.
All right, so let's do trapezoidal. So let's, again, think about what happens one sub-interval at a time. So one box at a time. We form this straight line. And this area is delta x for box number 1 times height 1 plus height 2 averaged. So f of f1 plus f2 over 2. f1 is just this height, f2 is this height. And then the second box similarly is plus delta x2 times what? f2 plus? Yeah, f2 plus f3 averaged. That's basically it. So this is how you computed the area.
So the integral will be integral of g of x dx.
Yeah, all right, perfect. So now for the numerator, we just do this with g of x dx. Okay, tell me quickly, what should I write here? This was? I want to discretize this numerically. So what should I write here? In terms of g, you can just tell me in terms of g. Is there any difference between the two? It's the same. There's one function, there's another function. So you write the same thing. G1 plus G2 over 2. G2 plus G3 over 2. Make sense?
Yes, but that makes sense. But what's G1?
I mean, here is what you said G1 should be. So we go one more step and we say x1 f1 plus x2 times f2 over 2 x2 times f2 plus x3 times f3 over 2. Yes? G is what you said G should be. G is x times f. So we do G with x times f. Is that okay?
Yeah. So x1 and x2. Okay.
x1 is 0, x2 is equal to 1, x3 is equal to 2. Oh, sorry. Yeah, x1 is whatever this coordinate is equal to 0. x2 is this coordinate is equal to 1. x3 is this value is equal to 2. Okay? No, f of x dx gives you the area. That's the denominator here. The numerator comes from this. This you already know how to do, the area. That's the easier one. Again, the numerator is identical. We just have to make one small substitution. No matter what's inside here, whether it be sine of x, exponential of x, some weird function of x, you can always go the same way as we did here. Any questions?
I have a question because from, oh yeah, it's b minus a. Yeah, okay, got it.
Okay, there's a question in the chat. Let me check. And for the numerical integration, how many individual boxes should we divide the function into? Okay. So there's a question in the chat that when doing numerical integration, how do we decide how many subintervals to use? So how do we decide here in this case?
Well, in this case, we have 3 points, so we pick the 3 points.
Yeah, in this case, we only have 3 data points. So we only have the possibility to create 2 subintervals. Remember, number of points is always 1 more than the number of subintervals. It makes sense, right? 1, 2, 3 points, box 1, box 2. So if you're given the data, you don't have a choice. You have to the number of intervals is basically decided for you. Any other questions?
So in real life, you will have to go and measure these points.
Yeah, in real life, you know, somebody is taking on January 1st, what is the temperature? They write it down. January 2nd, what is the temperature? They write it down. So you have all of these data points, and you can compute, let's say, the average using numerical integration. I mean, the worst thing you can do is just sum them all up and take the mean, but a more appropriate, better way is to use an integral to compute the average. More questions?
Yeah, basically the same question, but for like Simpsons rule, don't you need at least 4 divisions?
For Simpsons rule, what you need is at least 3 points. So this whole thing will start acting as one full, yeah, Simpsons rule is a bit weird because And do you know what I mean when I say that? Okay, let me write it down. So did I ask you to use Simpsons rule in the homework?
Yes, in I think 2 C.
Okay. So let me actually let me make this part of the notes so you have the details. So let me write it here. So note regarding Simpsons rule. Okay, Simpsons rule involves 3-point integration. So it's a 3-point integration formula. Okay, what that means is if we have this guy, so we might have the starting point and the ending point, but this is not sufficient because Simpson's formula is okay. I'm going to write h over 3. I will explain to you what exactly this means. So it's fi plus 4i plus 1 plus fi plus half fi plus 1. Okay, so the first thing you remember is Simpson's rule. We need 3 points. We only have 2. We have the left guy and we have the right guy. So this is I and this is I plus 1. What we need is at half, what's the value? I plus half. Okay, so we need this guy. If we know the curve function, it's easy to find this value. You just plug in the x value, you get the corresponding y value. In this scenario, h, what is h? So h is this distance. So h is this. Let me write out. So h here represents the width of the smallest subinterval. Used for forming the Simpsons rule. Okay. Is that okay? What I wrote here? If anything doesn't make sense, even a slightest bit confusion, ask me. I know this stuff is not familiar, so it's normal that something might seem off.
No, that's fine.
Okay. Anybody? Okay, perfect. So we know we need to use something like this formula. Now let's come back to our example here. The question from the homework here. What is h in this case? Give me the numerical value for h for this case. Yeah, h would be this guy, right? H. So it's 1 and 1. We would have liked to use these 3 points, one here, another here, and one in the middle. But there's no way for us to figure out what this midpoint looks like. So we don't do that. We instead treat these 3 as our full Simpsons interval. And each sub-interval corresponds to h. Make sense?
Yeah, that makes sense.
Okay, okay. All right. So when we write, let's say, let's write the area formula for this using Simpsons rule. So the area using Simpsons rule. And let me just write out the Simpsons rule here. It's h over 3 times fi plus fi plus half plus fi plus 1. Okay, so, oh, sorry. All right. So, okay, now you tell me, what should I write here? What will be the area in our specific example? And you can give me exact numbers, like 1, 2.5, whatever.
So 1/3 times 2.
Okay, y2?
That's f of 0.
Yeah, f of I, let's see, what's I? So that's guy. Okay, f of 0 is 2. A plus, oh, I forgot a 4 times here. So 4 times. 4 times.
So, Professor, I had the delta x over 6, not over 3 from the class.
I will tell you why.
Okay.
You use this always, okay? I'll tell you why in the previous note I wrote delta x over 6. So, but this is a formula which you use all the time. You will never confuse yourself. The other formula is correct. I will tell you why. So, okay, what goes here? 4 times what?
Okay, it's 0 plus 2 divided by 2 times.
Okay, so the reason you say that is 0 plus 2 divided by 2. Why 0 plus 2 divided by 2?
Well, if you take the full trapezoid.
This is not trapezoid. We're using Simpsons rule.
Yeah,
Use the formula here.
oh, I have. Okay, I didn't do that. Okay, so that will be 1 over 2.
You're saying f of half is 1 over 2? So, okay. Look, we need 3 points for Simpsons.
2.5, 2.5, 4 times 2.5.
Yeah, exactly. So we need 3 points for Simpsons rule. So these are the 3 points we decided on. The first guy, last guy, and this first, second, and the third guy. There's no way for us to do anything in between. So we have no other choice. So first guy is fi. That's what you told me to write the first number. Plus 4 times the second guy. That's the middle one. What is that? That's 2.5. And fi plus 1 for our case is this.
4.
Yeah, plus 4. Okay, that's it. That's the area using Simpsons rule. Any questions? Everybody know why these numbers are here?
Yeah.
Okay, and then if you were to do not area but centroid, how would you do this? Remember, we need to use this formula. We just need to adapt it so we can compute the centroid. Where do we start?
Would you replace the f's with x f of x?
Yeah, so see, you start just like we did here. These integrals don't involve any Simpson or trapezoid, they're analytical. So this is where the most simplified form ends up, well, that's where we end up. So just need to evaluate this using Simpson instead of trapezoid. We already did that using Simpsons. We replace all the f with g. You can do the same thing here. You replace all the f with g. So you just write h over 3 g1 plus 4 g2 plus g3. And just replace all the g with what it is, which is x times f. So this guy is x1, f1. This guy is x2, f2, dot, dot, dot. Make sense? No, yes, maybe. I'll be the happiest if you say maybe.
Makes sense to me.
Yeah, it does. Now, what's the difference between the 1/3 and the 1/6?
Okay,
That's
okay.
what.
Yeah, wait. So
Okay.
I'm still waiting for maybes. Okay, because you have to do this on the quiz. So if it doesn't make sense, you will not be able to do it. Okay, perfect. So now your question about why I tell you to use 1/3 when I wrote 1/6 in a previous lecture. So let me go back here 1 second. So the 1/6 was assuming your delta x is this full thing, right? This is xi plus 1. How do you define delta x? That's the difference between the two. And in this case, delta x over 6 would be exactly equal to h over 3. That's the reason why. So this full thing was delta x. Okay, so the formula is equivalent, but it's always, don't confuse yourself, always use this guy and always know what h represents. Does that answer your question?
Yes, sir.
Okay. All right, anything else? The y centroid? Okay, let me see where, okay. All right, so we did the x centroid here. How do you do y centroid? What's the formula? Yeah, so instead of x dA, you have y dA. And when you simplify this, you get f, oh no, I'm out of ink. F squared x, yeah, out of ink. Okay. Okay. And let me write it on the other side. So if you want to compute y centroid, you would do the integral y dA over dA. And this simplifies to f squared x dx half. Yeah, I mean, it's safest to always start here and then simplify it. You never miss the halves or the 1/3. Okay. All right. Now, how do you do this using trapezoid? So the top using trapezoid. Say that once more. F what? Again, anytime you find this confusing, just replace this thing with G. Okay, so this is G1 plus G2. G1 is F squared. So what's the next guy? Yeah, see, same. G2 plus G3 over 2. G is F squared in this case, so we get that. And you do this the same thing for Simpsons rule. So see, no matter what's inside, you always know how to convert it to simple trapezoidal rule and Simpsons rule. Okay, next question.
I'm still on that, on the centroid, the Y centroid Z.
Oh,
You're trying to F1.
okay, tell me which step.
Delta X F1 plus. Oh, okay, from the Simpson rule. Okay, got it. From the trapezoid.
Yeah.
Oh, okay. So then, yeah, I'm good.
Anybody else? Okay, next question from the homework.
That would be G.
Okay, again, this is the same thing. Instead of F squared, for one guy, you'll have F cubed, and you do the same thing. Do you know how to do it analytically?
Yeah, I think I did it.
Okay, tell me the formula you wrote down for Ix or Iy.
So I use the parallel theorem. So Ix, which I call IXC, the centroid. Let me go back here. Okay, so that's the integral of y squared dA, and that's double it, yeah, and then it's the integral of 0 to 2, the integral of 0 to f of x, y squared dy dx.
Okay, next.
It's equal the integral of 0 to 2, y cubed over 3 from 0 to fx dx. So that's 1/3 the integral of 0 to 2 f cubed x dx.
Can you integrate this numerically?
Oh, yeah, that's 0 to 2. Yeah, I just cubed the f of x.
Yeah. F1 cubed plus F2 cubed, etc. This is for IXC, yes. IX, you just use parallel.
So Ix is equals IXC plus AH squared.
Correct. And that H, don't confuse that H with the Simpsons H.
Yeah, no, I know.
Yeah, that's it. So IY, again, same. Once you know how to do the steps, it's the same everywhere.
Yeah, analytically, we're very familiar with it. It's the numerical letter.
Yeah, so I mean, analytically, all you need is to come here, this simple step. Once you are here, trapezoidal is very, very straightforward. Replace this as G, and then just you get delta x1, G1 plus G2 over 2, etc. Okay? All right. More questions?
So how do, yes, okay, that will give me the centroid, but it doesn't give me the IX.
Doesn't give you what?
Oh, okay, okay, I see what you're saying.
Yeah.
So I go, so how would that look like? I just want to see
How would what look like?
that integral numerically.
You tell me.
So it will be 1/3. So F1 cube plus F2 cube divided by 2 times, that's delta X, or yeah, and so on.
Good. For this guy? Wait, what? Say that once more. Oh, yeah, IX is much simpler. You don't have to do anything. IX is IXC plus XC. What is it?
Yeah, times H squared.
YC times area. This is your H squared, the distance from the rotation axis of the centroid.
Yeah.
Yeah, there's no integration here. You have the numbers for all of them. Okay. All right, next question. Oh, there's no more next question. Okay, anything else? Everybody is clear on how to follow these steps? All right, so let's go back and let's go back and talk about a three-dimensional example. So since, remember, everything we talked about right now in 1 and 2 dimensions applies to 3 dimensions. It's the same concept. So let me write an example. Let me use a new page. The half ordinates of the water plane of the ship. Or ordinate is just the y coordinate. That's usually the name. Abscissa is x, ordinate is y. Okay, so these values are given here. Let me write station. Let me write the offsets first. Did I miss one? There should be 10 of them. 0, 9, 12, 13, 14, 12, 11, 7, 5, 0. Oh, I missed one. Okay, okay. 2 14s. Okay, and station 0 is the aft perpendicular. Station 10 is the forward perpendicular. All right, so anytime you're given a question, always visualize it in your head. Can you tell me what this looks like? What's given? There's more to the question, but first let's visualize what we already have. So you're saying station 0 would be at the stern, okay, and what? 10 would be? At the bow, yeah, that's corresponds to the forward perpendicular. These are distances from the perpendicular. Not correct. So let's look at what's water plane. So these coordinates describe the water plane in some way. If we, let's draw a sketch of a water plane. So looking at it from the top, roughly this is what it would look like, right? So now let's think about this. Let's mark AP and FP. Where's AP, where's FP? Where's AP?
AP's on the left.
Okay, so let's mark that here. And FP is here. All right, now can you imagine what these coordinates mean? So let's say station. So it's basically cutting this up into 10, slicing it up like this, correct? So we are basically looking at station 0, station 1, 2, ... and we end up at 10. All right, what do the red coordinates give you? Half ordinates. What does that mean? Look at the values and it might make sense.
Those are lengths from the water line.
Lengths from the water line. So this the red outline is the water line. That's when we cut the hull along the water line. That's the section we get, the cross section.
Lengths from the center line in the y-axis.
Yeah, the red coordinates give us the distance between the center line and the location of the hull. Okay, so you see at station 0 we are y value is 0. Station 1 y value is 9. This is 12. and so on. And once we reach station number 10, that's the end point. Again, the y value is 0. So our hull comes back and basically comes down to 0, 0 span. Okay. What about the distance between each station? Can you tell me what that would be? Do we know what this distance is, what this distance is? Yeah, it's 180 divided by 11. So, see, you told me 11 because you have 11 numbers here. Always use your hand. Yeah, 10 divided by 10. 5 points, 4 divisions. Okay. So this is 18 meters, 18 meters. So the distance between each station is 18 meters. It's not said it's uniformly distributed, but unless it's explicitly mentioned that distance is not uniform, so one might be 18 meters, another might be 10 meters, another might be 20. If it's not given explicitly that that's the case, we assume uniform distribution. Okay. Now tell me, why might this be useful? Why is this information useful? Think about what we were just doing. What can you do with this information? Let me mark coordinate number 1. This is 0, 0. What is this coordinate? This is, what is this?
19,
18, 9.
18.
This is the x value is 18. Y value is 9. This is the I, right? I is equal to 1, I is equal to 2. Not x equals 18, not x equals 1, not x equals 2. What about this guy?
3612.
Yeah, 3612. See, and you have these coordinate values for all of the 10, 11 stations given to you. Okay, now think about what I asked you. How can you use this information? Geometrically, what can you do? Can you compute the area of the water plane? It's basically the integration we've been doing in the previous pages. You can compute the area of the water plane numerically, just knowing these values. What else? Is that it? Is the area the only thing you can compute? You can compute the centroid. Give me one of the ones we know already.
It'll be along the center line.
Yeah, the centroid will be along the center line because it's symmetric. So we can compute the LCF. Okay, longitudinal center of flotation. That's the centroid of this water plane area. You can compute IX. You can compute IY. You can compute IXC. Anything you want, you can compute. Okay, just using these data points. And that's exactly what we will do. So let me write the rest of the question down. So the first is compute area of water plane using trapezoidal rule. Number 2 is do the same using Simpsons rule. Compute the centroid All right. All of the questions make sense now? That's basically everything we've talked about. Area, centroid, area moment of inertia.
Yeah, it makes sense.
Okay, perfect. So again, always, anytime you're given a question, not just in ship hydrodynamics, anywhere, and any engineering problem, always try to visualize it in your head. And if you have paper and pen, start sketching. So the same sketch that I drew earlier, I'll make a nicer version here. So I haven't drawn 11, but dot 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 meaning, some missing. X, yeah, let's use the same subscript xi. So x0 is 0, x1 is 18, x2 is 36, dot dot dot, x10 is 180 meter. And similarly, we have the corresponding fi values given, the y values. In here, delta x is 180 over 10 is 18 meters. All right, question 1, area the water plane. What do we do?
You just estimate it numerically.
Okay, so before we go to the numerical part, let's, how do we start analytically? What do we write?
It's the integral of f of x dx.
All right, so let's start with even before that, double integral of dA, right? And you'll see why I'm doing that. So x goes from 0 to L. What does y go from? Does it go from 0 to fx?
Yes.
Think about the shape we have and what happens with the full hull. Zero would be here, fx would be here. Is that the only area we want?
So you want to go from negative f of x to f of x?
Yeah, so see, there's like a mirror part that I haven't drawn. So you would go from negative f of x to f of x. And inside you have dy dx. So it's what you said, but 2 times that. I mean, intuitively you can see what you compute will be half of the water plane area. So 2 times that gives us the full thing. So this ends up being 0 to L f of x dx. All right. So the first question says use trapezoidal rule. So trapezoidal rule. All right, help me set it up.
You start with delta x.
Okay, so let's put the 2 outside and delta x.
Times f of 0 plus f sub 1 over 2 plus delta x times f1 plus f2 over 2.
Yeah, that's it. So see, once you get the correct simplified integral, after that it's a no-brainer. Okay, and would you be able to do the same with Simpson's rule?
Yeah.
All right, so let's just write it out. Simpson's rule would be what?
Uh, 2 times delta x over 3 times in brackets, I guess. F naught plus 4F1 plus 2F2.
Just F2.
Just F2.
All right, next one. Help him. Others.
For F3 or F3, right? Next parenthesis.
Did you say F3?
Well, we factored it out, so yeah, makes sense. X of 3.
Okay.
It should be F2. Right.
Oh yeah.
Yeah. So, all right, let me write it out and then I'll tell you why. So it should be F2 plus 4F3 plus F4 plus dot dot dot. Okay, so let's go slowly over what happened here. 2 is just a constant here. We take it out, get it out of the way, and the integral is what we have to deal with. So first, Simpsons rule, I told you it's h over 3. Okay, here, look at this. We need to use 3 points, the first 3 points, to form the first Simpsons interval. Okay, h is distance between these two, which in our case is delta x. Okay, so again, don't confuse this with why it was delta x over 6. You can forget about the delta x over 6. Always use h over 3. So this is my h, delta x over 3. First point is f0, second point is f1, third point is f2. That means the first 3 points are done, they are dealt with. Whatever's inside here has been computed. Then we move on to the second uncomputed section, which is point number 1, point number 2, point number 3. Okay, so we move on to this guy. For this new subsection, again, h is the same as before. It's delta x, 18. The first point is f2, which is why I wrote f2 here. The second point is f3, which is why we have 4 times f3. The third point is f4, which is why we have f4. Is that okay? Again, not okay is what will make me happiest. So say it's not okay. All right, we're not moving forward unless you ask me at least one question. I will wait. So one question is, can we write that as a summation? Yeah, of course. So look, you see a repeating pattern. 0, 1, 2, 2, 3, 4. Yeah, it'll just be a summation. So if you were to write this as a summation, you would just do 2 is a constant, so we keep it outside. Summation of what? Hi over 3 fi plus 4 fi plus 1 plus fi plus 2.
If that was in terms of like the first part, wouldn't the next have to be f1 plus 4f2 plus f3?
Hmm? Mm.
Upper part, where it says of x over 3 f2 plus f4, just above this.
Okay, wait 1 second. So tell me the limits. What should I go from to what? Yeah, 0 to, not to 10, but to 8. Yeah, 8. I goes from 0 to 8 because you'll run out of points once you reach I equal 8. So this guy will be 10 and there's nothing left after that. In trapezoidal rule, this is okay. The I equals 0 to 10 would be okay because we have each interval corresponds to one box, but now we are basically smooshing two of them together. Okay, now ask me what you were saying.
So like on that second part,
Hmm.
you have f2 plus 4f3 plus f4.
Okay.
Like how would you get that from there? Wouldn't it be f, and that second part summation would be f1 plus 4f2 plus f3.
Oh, I see. So you're saying if I plug in I equal 1, we'll get a weird.
Yeah.
Yeah. That's why these indices always mess me up. So let me think for 1 second. Yeah, no, don't write this index. This is wrong. Yeah, because the way you would do this is you'd combine all the, see, there's an F2 in here, there's an F2 in here. So you'd combine them. You see, the same thing will happen with F4 and the F4 in the next guy. So it's more involved. So don't write this. Yeah, sorry. There is a nice clean formula, but then you have to think about how the indices correspond to all of this. If you really want to know that, ask me later, but it's easiest if you just go interval by interval. So what's the first Simpson interval? Look at 3 points, form your sum. What's the second one? Next 3 points, form your sum. Don't miss here, because if you don't include this guy in the next summation, you'll have an empty area here, which you don't never account for. So just go step by step. Writing this in code is easy because you just write a for loop with the correct indexing, and that's it. Yeah, you just skip every 2. You start at 0, skip by 2, start 1, skip by 2, skip by 2. Okay, so more questions about this? The homework example we were looking at was as if you only had the first guy. You only had 3 points given, so we only had to worry about one Simpson interval, but now we have many more. One Simpson interval dealt with in the first term, second Simpson interval dealt with in the second term, and so on. Is that okay?
Yeah, it's okay.
Okay, all right. So if you were to come, so that's basically question 1 and 2. 3 says compute the centroid of the water plane area starting from the aft perpendicular. So starting from here. Okay, so that's number 3. Oh, that was number 2, right? So this was number 2. So number 3 is centroid of the water plane. So xc comma yc. You know how to do this? Oh, let me help you set it up. So again, it's the same as we did for the homework example. So xc will be double integral of x dA divided by area, which is 0 to L, y equal negative f to plus f x dy dx. So this simplifies to 2, 0 to L, x, fx, dx. No, for area. Oh, sorry. All right, area we just computed, the top guy. Do you know how to compute the top guy? That's basically what we did in the homework. So it's the same. Y centroid. What will be YC?
YC will be 0.
Yeah, YC will be 0, right? It will be along this line, which is y equals 0. Can you see that from the integral? How will it show up? YC equals 0? Will this equal 0? What happens when you integrate this? Okay, tell me what goes inside. I'll put the limits. So this is negative f and plus f. What's inside here? Okay, y squared over 2. When you plug in the upper limit and the lower limit, you'll get 0. That's another way to show that YC is equal to 0. And this is equal to 0. Okay. What was the next question? It was compute moment of inertia. So I about longitudinal axis, meaning I x c equal what? Same as before, this is equal to double integral y squared dA, 0 to L, y is minus f of x to plus f of x, y squared dy dx, 2, 0 to L, f of x cubed over 3 dx. Once you're here, you know how to solve this numerically, either using trapezoid or Simpsons rule. This is the longitudinal axis. Transverse. IYC again, same thing. You do x squared dA and you integrate. All right. You will be able to do this on your own, or do you want me to do any of it?
I think I could do it.
I mean, if you get to here, you know how to go further. You know how to integrate this using trapezoid and Simpsons. IYC, if all you have to do is start here, x squared dA, and you'll end up with 2, what will it be, 0 to L x squared f of x dx. Once you're here, you know how to integrate this. You replace this with a g and do trapezoid or Simpsons, same thing. All you have to do is start at the basic formula and simplify it as far as you can analytically before you turn to numerics. Any questions at all? All right. Next class, we will do one more example, and then we'll start talking about stability. For homework 2 is up. Please take a look. Oh, well, finish your homework 1 first, and then take a look at homework 2. Quiz will cover both homework 1 and homework 2. And we've pushed it back, so it's on February 12th. Any questions? All right, so I'll see you on Friday.